This is 6.2 Law of Sines. The Law of Sines defines the relationship between sides and angles in any triangle. What we've been doing up to now has been, when we found cosine and sine, those were for right triangles. And now we can use, what's really cool about Law of Sines is that it's good for any triangle. It doesn't have to be a right triangle. And this is what it says. The triangle ABC, so you have a triangle like this. A, B, now let's put B up here. A, B, C. That the sine of A, angle A, which would be right here, divided by the side A, and side A is directly across from angle A. Okay, so the sine of A divided by little a is the same as the sine of B divided by side B, which is the same as the sine of C divided by side C. Okay, so what we're going to do is prove that this is true down here. It says let triangle ABC be any triangle. So here's A, B, C. So if this is angle A, then the side that goes with it would be directly across from it, and that would be a little a. This is angle C. The side across from it would be little c. Okay, so from what we learned before, okay, sine of A would be equal to y over r, or opposite over hypotenuse. That would be h over c. Sine C would be equal to the same thing, opposite over hypotenuse, or y over r, so h over a. Now, what do they have in common? They both have an h, so we're going to get h by itself. In order to get h by itself, we multiply both sides by c. Those c's cancel, so we have c sine of big A equals h. And over here, we'll multiply both sides by a, so those a's will cancel, and we have a sine c equals h. Okay, so now they're both equal to h. That means we can set each one of these equal to each other. So we have c sine of A equals a sine of c. This should be a big C though, because we're talking about the angle C. Okay, so now what we want to do is we want this to look like this up here. Sine of A over A equals sine of C over C. Okay, so if we need to get rid of the C and we need to get rid of this A. So let's divide by C and A on both sides. Okay, these C's cancel, these A's cancel, and we end up with sine of A over side A equals sine of angle C over side C. Okay, and we just proved that the law of sines is true. And this is probably how it was discovered. Okay, now we're going to use these ratios to find parts of triangles that are missing. It says the law of sines can be used to solve triangle problems where a side angle pair is known. So like you know angle C and you know the side that goes with it, the little c. And one other side or angle is known. So let's do triangle ABC. Okay, this would be A, B, and C. It doesn't matter how you label it. Okay, angle B is 35 degrees. Angle C is 50 degrees. And little b, which is across from big B right here, is 9. Okay, we can find the angle for A just because we know that the angles in a triangle add up to 180. So we're going to have 180 degrees minus 35 degrees minus 50 degrees. So 180 minus 35 minus 50. That gives us 95 degrees. So we know angle A is 95 degrees. Okay, now we're going to use our law of sines to find the sides. And the pair that we know of, we know that the sine of B, or the sine of 35 over 9. We can put those two together. So the sine of 35 degrees over 9 equals let's find A. So we're going to do the sine of 95 degrees over, and little a is across from big A, over little a. So then we can find this A. Let's cross multiply them. So A sine of 35 degrees equals 9 sine of 95 degrees. And then solve for A. So we want A by itself, so we'll divide by the sine of 35 degrees, and those will cancel. And divide the other side by the sine of 35 degrees. And then we'll plug this in the calculator. You got to make sure your calculator is in degrees, always when we're working with degrees. Then we'll do 9 sine of 95 divided by sine 35. So that equals 15.631. We're going to go to 3 decimal places on the sides. Okay, so that is side A. Now we're going to find side B, or side C. Little c is across from big C. So we'll keep starting with the sine of 35 over 9. That equals the sine of 50 over C. Cross multiply them again. So we have C sine of 35 degrees equals 9 sine of 50 degrees. Divide by sine of 35 so we can get C by itself. So C equals, we'll plug this in the calculator. So 9 sine of 50 divided by sine 35. Can you wait? You come in. That equals, I thought you were the janitor. Equals 12.020. I'm recording. Okay, so I can't stop it either, I'm sorry. Oh, you want to show me real quick? They can wait. Oh, yeah, that's how it was. Okay.
It'll be okay.
Yeah, that looks good. Sorry, you got to get this done for my people that were absent. Okay, so we got A, triangle ABC. Triangle C is 30 degrees. Across from angle C is a little c. Okay, we don't know the angle of B, and we don't know the angle of A, but we know across from angle B is little b, and across from angle A is little a. And C equals 7, and A equals 10. Okay, so we can find some missing angles here and sides. The pair that we have is sine of angle C, which is 30 degrees, over 7, because we have the side and we have the angle for those, equals the sine of A over 10. Okay, then we'll cross multiply these. So we have 10 sine of 30 degrees equals 7 sine of A. Divide both sides by 7. So you get sine of A equals 10 sine of 30 degrees over 7, because these 7's cancel, and we get sine A by itself. Okay, but here it is. The problem is we need the angle A. So whenever we find an angle, we need to get rid of this sign. So we use inverse sign. So we say angle A equals the inverse sine of 10 sine of 30 degrees over 7. So we're going to put that in the calculator. We'll do second sine to get the inverse, and then 10 sine 30, close parentheses, divided by 7, close parentheses. Okay, so angle A is rounded to 46 degrees. For angles, we round to the nearest degree. For sides, we round to 3 decimal places. Okay, so we have angle A. Now let's find angle B. So let's start back with sine of 30 degrees over 7. That's the C and little c. equals, we need angle B. If angle A is 46 degrees, we can find angle B because we know that all the degrees in a triangle, all the angles in a triangle add up to 180, so we'll subtract 46 and subtract 30, and we get 104 degrees. Okay, so sine of 30 over 7 equals the sine of 104 degrees over B. Cross multiply. So B sine of 30 degrees equals 7 sine of 104 degrees. We're going to get B by itself, so we divide both sides by the sine of 30. Okay, so little b equals 7 sine of 104 degrees divided by the sine of 30 degrees. Okay. Okay, this is not an angle. This is a side we're finding. So we don't do inverse side. We just do what it says right here. So we're going to have 7 sine of 104 divided by sine of 30. And we get 13.584. We're going to see if that makes sense. Side C is 7, side A is 10, and so yes, that does make sense. It's about around the same size as those. Okay, for your homework. Homework is A6-2, numbers 1 through 15 odd. You've got some review problems in there. Here, I'll show you two. You've got okay, 6-2, numbers 1 through 15 odd. So 1 and 3 and 5 and 7 and 9, you use the law of sines. And then starting with 11, 13, and 15, okay, these are review. On 11, you convert each angle below from degrees to radians. What you want to do is multiply by, I don't know if you remember this, but pi over 180 degrees. Okay, because there's 180 degrees in pi. And leave these in terms of pi. Okay? And then on 13, find two angles, one in a clockwise direction and one in a counterclockwise direction that are coterminal to the given angle. Well, clockwise direction, you're going to subtract 360 degrees. In a counterclockwise, you're going to add 360 degrees. Okay, or down here, you're going to add 2 pi, subtract 2 pi. Okay, and then 15, you have to draw your quadrants about all students take classes and see when the cosine of theta and the cosecant of theta have opposite signs, and when cosecant theta is negative and tangent is positive. Okay.